April 2014. The team that has set out to develop the world's first battery storage system for a wind park is convened in the Faroe Islands. The Danish engineering company P.A. Petersen is one of SEV's oldest advisors, with a thorough knowledge of the Faroese power grid. Peter Winter from P.A. Petersen chairs the project group.
Jamen det der jo er det helt unikke, det er, at der ikke er nogen forbindelser til omverdenen. At man skal være i stand til at balancere systemet sekund for sekund, alene ved egen hjælp. På kontinentet Europa, der har man 30 sekunder til at redde situationen, hvis et kraftværk falder ud eller vinden forsvinder. Her på Færøerne har man kun 2 sekunder. Og det kræver altså, at vi bruger nogle nye teknikker, som for eksempel batterilagring, som er det, vi har projektmøde om i de her dage.
If, for instance, the hydroplant Aya that the group is seen visiting shall be able to save the situation, it is important that the battery system in Husahøya Wind Park can hold the power supply up for the necessary crucial moments. This may seem a straightforward task, but considering that the battery must be able to deploy and receive several megawatts in seconds, the task gets more difficult. So difficult, in fact, that it still hasn't been done. So far.
Den helt store vanskelighed er, at der er jo ikke skrevet nogen lærebog om det her. Vi er derude, hvor vi skriver lærebogen efterhånden, som vi arbejder med tingene. Den første landvinding, det var egentlig, at vi i februar fandt ud af, hvad der ville være den rette størrelse af batteriet. Det er dyr teknik. Man skal helst ikke købe det større end allerhøjst nødvendigt. Og det vi er i gang med at finde ud af nu, det er, hvordan vi så skal indstille batteriet og få det til at samarbejde bedst muligt med det færøske energisystem.
The battery comes from the world's foremost battery manufacturer for industrial use and special needs, from aeronautical to space. For SAFT, the battery system in Husahøya is an exciting challenge.
Our lithium-ion batteries are most suitable to do this job because first they are highly reliable products for a very long life, up to 20 years. Secondly, they are suitable for a huge number of cycles, and we calculated the number of cycles will be huge with a throughput per day of several complete charge discharges, but in fact it's a huge number of small cycles. So I hope our batteries can contribute to stabilize the grid at this island. It's also a good experience for us and a good example for the future, how to cope with energy problems and how to shift energy production from conventional diesel power plants to renewable energies.
Enecon is the world's third largest manufacturer of wind turbines. More than 22,000 are in operation around the world. But the Faroe Islands pose some unique challenges for Enecon's wind turbines.
The challenge for myself and in my tasks is to adjust these parameters that you cannot touch, that you cannot see. No hardware is affected, but you nevertheless have to find the right settings that at the end the wind farm and the grid cooperate in the right way.
The project to stabilise the grid with batteries isn't only interesting for the Faroe Islands. For Enecon, the power grid in the Faroe Islands is a great place to learn about the future.
The Faroe Islands are a little bit a laboratory for the rest of Europe in the next years or decades. Because it's so small, certain technical problems appear that will appear in 5 or 10 years from now in other areas of, let's say, United Kingdom or Central Europe or so. So this is for us an early way to learn something, and additionally we see other projects with isolated grids like on the Canary Islands or in Asia or in the Caribbean Sea where the question is very similar. And here we have the big benefit to have the customer and the power system operator being the same. So we can have very close discussions and very open discussions. Meanwhile, in other projects, you maybe have a customer that is only interested in producing power and feed it into the grid, and he doesn't care for the stability of the grid. And here, the system operator is the customer. He's responsible for the stability of the grid. That makes us here in a very positive environment. We can learn a lot here.
I guess you have seen also that there are some annexes. So it's a real, I mean, it's not a mistake.
No.
Both Enercon and SAFT gain many advantages from working with SEV. The small, isolated Faroese power grid, with its diversity, is a great model for the future.
I'm impressed that you are using here at your islands a lot of different energy sources like diesel, wind, and water power. So it's I would say it could be a real good example for Europe to learn how to establish the different sources of energy.